All right, this video is on converting between fractions and decimals. All right, so first of all, we're going to look at a fraction and see how to turn it into a decimal, okay? There's two ways to do it. The first one is if you notice your denominator, remember is your bottom number, is easily a factor of say 10 or 100 or 1,000, any multiple of 10, then you can change it into that denominator. So for example, 25, if I multiply it by 4, I get 100. Remember equivalent fractions, yeah, also multiply the numerator by 4. So 19 times 4, you get 76, okay? So 76 hundredths is what that fraction is. Well, 76 hundredths is also a decimal, which is 0.76. So that's one way to do it. But the problem is that only works if this denominator is a factor of 100 or 10 or 1,000 or something like that, which is not always going to be the case. So your other option that will work no matter what the fraction is to divide. Remember, this fraction bar means division. Okay? And remember, you always divide the top number, the numerator, by the bottom number, the denominator. Now, these are fractions, so clearly they're going to be less than 1. So 25 doesn't go into 19 at all. And we're turning into a decimal, so I'm going to add that decimal point in there. So now I want to see how many times does 25 go into 190. Luckily, we have a little bit of a cheat here because we see it's 7. But you could also just try trial and error, okay? So remember, 25 times 7, if I plug that in, it would be 175. Do my subtraction and my borrowing. And then 25 into 150, it goes in 6 times. And then I'm done. So you see, doing this method, we also got the same answer, 0.76. And the nice part about this method with the division is it'll work no matter what your fraction is. All right, so 8 2/3. I want you to go ahead and pause it and use the division method to try and figure out what that 2/3 decimal would be, and then hit play to check your answer. All right, so 8 2/3. So 8's not going to change. It's not a fraction or a decimal. It's a whole number, so it's still 8. But I want to figure out, okay, what is 2/3 going to be? So 2, the top number, divided by 3, the bottom number. So obviously it's not going into 2 at all because we already have 8 as our whole number. 3 goes into 26 times. I get 18. I subtract, I get 2. And you just keep adding zeros. But you quickly realize, look, I'm dividing it to 20. No matter what, I'm going to keep putting a 6, getting 18, putting a 2, getting another 20. So as soon as you realize you're dividing into the same number again, that means your decimal is repeating. The way you show that's repeating, and repeating just means it's going to keep going forever, right? I would keep doing this for forever if I kept going. The way you show it's repeating is you put a line over top of it, okay? So my answer is 8.6 repeating. I could put both 6s, I could put 3 6s, it doesn't really matter. It's just 6 is repeating. So 8 2/3 is equal to 8.6 repeating. So here's our two different types of decimals we talked about. We talked about repeating decimals and terminating decimals. So repeating goes on forever, like we showed. It goes on forever, but it goes on forever in a pattern. So it's not random. And that's important, okay? So you could just have one number like the 0.6 repeating. You could also have 0.25 repeating, okay? You could have some numbers and then have just the last one is repeating, so 0.87555555. You want to be careful when you're writing your repeating because if that's what happening is different than this happening, right? This would be 0.87 and then the 5's going on forever versus this is 0.875 repeating, so the 875 keeps repeating. So be careful what you put the bar over because whatever you put the bar over is exactly what's repeating. Terminating is every other decimal you're familiar with. It's just a decimal that stops eventually, okay? Terminating, like the Terminator, he ends people's lives. It's a decimal that ends, okay? So decimal that ends at some point. It might go for a little while. It could have a lot of digits, but as long as it ends, it's terminating decimal. So you could have anything from just 0.5, a normal 0.5, or you could have a big long number that does all the way to that before it stops. Okay. Okay, those are both terminating decimals as long as they're not going on forever. So go ahead and take this fraction and turn it into a decimal using your division. Then hit play to find your answer. All right, so this one's an improper fraction, if you noticed. So you have two options. You could turn it into a mixed number and then divide, or just go ahead and divide. I'm just going to go ahead and divide. So remember, it's always the numerator is inside, the denominator is outside. So since this is improper, it's going to be greater than 1. So before we get to the decimal, we're going to have some division. So it goes into 15 once. Goes into 60 6 times. And then this is the point where I start adding my decimal. Don't forget to add it to your answer. That's important. And look, I'm getting 60 again. As soon as that number 60 repeats, you know the problem's repeating. So this 6 up here is repeating. I'm just going to keep getting 6. So 150 over 9 is equal to 16.6 repeating. Make sure you add that decimal and the 6 because you don't want to write it like that. That doesn't really make a whole lot of sense. Only numbers after the decimal can be repeating. So that's why I needed to write that 10th and have it be showing as the repeating one. All right, turning a decimal into a fraction. This is actually easier than fractions into decimals. And the reason is all you have to do is just say it. I'll show you what I mean. So a lot of us would call this 0.6, but it's actually not its official name. 0.6 is really 6/10. Because this decimal point right here is the tenths place. Well, so 6/10 can represent this, but 6/10 also represents this. So all you have to do is be able to say it. It's 6/10, so 6/10 as a fraction is written like that. Once you get your fraction, the only other step you have is to simplify it. So look for common factors that both the numerator and denominator can be divided by, and then you have your final answer, okay? If you're not sure of place values, another trick is for each one place value will mean 1 0 in the denominator. So go ahead and pause it, try this one on your own, turn it into a fraction and simplify it. All right, so 4.85, just like before, the 4 is still a whole number. And then I have 85, and that's hundredths. Or other trick is just count 1, 2, so I should have 1, 2 zeros. So that's my fraction or a mixed number, but make sure you simplify it. So both of these are divisible by 5, knowing from my divisibility rules. I still have 4. 85 divided by 5 would be 17, and 100 divided by 5 would be 20. Don't be afraid to do the division out. You want to make sure you don't make a mistake. And then 17/20 is simplified. So that would be 4 and 17/20. Again, pause it, figure out your fraction, and then hit play to get your answer. All right, so this one, again, the 6 stays there. It's a whole number. And then we have 8, and it's in the 1, 2, 3. So tens, hundreds, thousands, or just make sure you put 3 zeros since it's 3 places. So that's our fraction or our mixed number, and I want to simplify it. So one thing you can do if you're not sure, if they're both even, just keep dividing by 2. It's definitely loud. But if you use your divisibility rules, you would also see that since there's 1, 2, 3 zeros there, it is actually also divisible by 8. I'm going to keep just cutting it in half to kind of show in case that's the way you did it. So you can see. So divided by 2 again. Don't forget that 6 is still there. And then again, divided by 2 one last time. 6 and 1, 125ths. So there's our decimal converted into a mixed number. Finally, I'm going to show you how to put our decimals in order from least to greatest when you're dealing with repeating decimals, because that makes it a little trickier. So what I end up doing is I list them vertically. Rewrite all the numbers vertically. Once I've done that, so there's all my numbers, I'm going to add a couple digits to the end of each one. So like this first one, since 8 is repeating, it's going to have 8s after it. Since this one's terminating, there's no repeating, it's going to have zeros after it. Again, terminating, so it has zeros. Terminating, so it has zeros. And then this one's repeating, so it's going to have 8s. So I'm filling it in so that it goes to an equal place value, so I can compare. Then I start going down the line, and I notice that this one, and this one all have a 0 in the tens place. So they're the 3 lowest. Then I look at the next place, 0, 8, 0. So these two are vying for the lowest. They have an 8 still, and then this one finally has a 0 compared to an 8. So this one right here is my first digit, my first decimal in my line. And this would be the second. They're ever so slightly different because this one has an 8 repeating, and this one just has an 8 with zeros after it. Then that would make this one the third, since it was 0, but then it had an 8. So it was significantly bigger than the other two. Finally, I have my two that start with an 8 in the tens place. And they also both have the 8 in the hundreds place. But then this one has a 0 and that one has an 8. So this one is a little bit smaller, and that makes this one the biggest. So I want you to use this technique. Go ahead and pause it and list these out, filling out some digits after they're showed to stop on here. And then compare them to find out the order from least to greatest. All right, so I'm going to again put them in order. Or not in order yet, but list them. And then after I list them, fill in some numbers. So I'm going to go maybe 3 more spaces. So if they're terminating, it's just zeros. If they're repeating, show what's repeating. So this is 2, 5, 2, 5 repeating. And this is terminating, so it's all zeros. All right, so now comparing, these two have 2s in the tens place, everything else has 5s. And we compare those, they both have a 5, and then this one has a 2, that one has a 0. So this one's the smallest, this is the second smallest. All right, so I've done those two. Then I'm comparing all these ones with 5s in the tens place. It gets pretty easy because the hundreds place narrows it all down. So 0 would be my third spot, followed by the 2 would be the fourth, and the 5 would be the fifth.